Okay, so we're going to be using graphs and tables to approximate solutions. And I do mean approximate solutions. We will actually figure out how to solve in a different lesson. But this is just a general approximation and trying to understand how I can use some of my knowledge and my best guessing to figure out a pattern of what we have. So when you have a home run has 32 feet of fencing to build 3 sides, that's important, 3 sides of a rectangular chicken run. In other words, the building that it's up against, it does not need to be figured into it. I'll just use B for building because that side does not have any fencing along it. So the question is, if I pick some random widths, I can calculate the length, right, by, plugging it in, right, 2x plus 8. Suppose we start with a width of, make the chicken run 8 feet wide. Well, of course, you're going to take the 8 to the other side, and that would be 2x equals, if you subtract 8, you're going to get, what, 24? And so we could divide by 2 and find out that we have 12. Okay? Now, everybody knows that length times width is your area. So we would multiply those two things together, 8 times 12, and get an area of 96 square feet. Okay, and so we would continue doing this process. If we make the width 12, that's going to bring the length down to 10. And now we have an area of 120. So obviously the area is getting bigger. We're still using the same 32 feet of fencing, but if I configure the width differently, so is that pattern going to continue? Let's see here. So 16 feet. So let's see, we take 16 away from the other side, so that would be 2x plus 16 equals 32. 2x equals 16, and so now we're down to 8 feet. 16 times 8 off the top of my head. That'd be 80 plus 48. 80 plus 48, that's 128. So still getting bigger, but definitely not by much. Let me just verify that, but yeah, I think so. And then lastly, if I made it 2x plus 20 equals 32, subtract that to the other side, that's 2x equals 12. And so we're talking about, we're back to 20 times 6, that's 120. So it would actually be now getting smaller. So you can see that as I was increasing the width, for a little while it was going up, and then all of a sudden it started to drop. So there is some sort of maximum area we could be trying to find, and that's kind of the goal for this. Write a function for the area in terms of the width. Okay. So in other words, they want me, so the width here is y. They want me to solve for y. And they want that function to be using area. Ooh, okay. So algebraically, we have area equals x times y. Now, we could solve that equation for, let's see, what do we want to solve for? Let's solve it for x. No. Is that what we want to do? Yeah, we do want to solve it for x. Okay? Because we don't want, we called length y or width y and length x. And so we're getting the y by itself. Is that what we want to do? No, we don't, because we want to replace it in the other equation. We want to be able to come up to this equation and replace the x with something. That's what we want to do. So let me go back to this equation. Hold on a second. Let me pause. Okay, so since we want to replace the x, we have to solve this equation for y, or solve for x, by getting rid of the y. So now we know that x is equal to a over y, And now we can bring this over and drop it into the other equation, a over y. So now we can say 2a's over y plus 1y is equal to 32. And now we have an equation that has... Now, at this point, I think it's a little bit extra for us to solve this equation for y. We could do that. But I think at this point, because there's two y's involved and it's not as easy with the algebra, we're going to leave this equation as is. We could take this, you know what? We could take this equation to Desmos and see if we could find the maximum value. That's a good idea. All right, let's do that. Let me pause. All right, so as you can see, I had to substitute the letter x. You know, Desmos doesn't know that A is the area. It likes to use x and y. So I just decided to replace A with x. And so now it gave me this picture right here. So in our case, the A is the, or the x in this case, is the area. Okay? And you can see that it's got a high point right there. Now I know you're thinking, well, wait a second. What do you mean a high point? Well, it's an extreme value. So 128 was the highest value. I just happened to guess it when I was making my chart because I just randomly chose a width of 16, which gave me a length of 8, and, worked out to be the actual highest value. So it doesn't always work out that you can, figure that out that quickly, but my goodness, I guess I did, even accidentally. But it did work out. Anyway, so using graphing technology, we can prove that we are correct at being the maximum value. And I know, folks, that they didn't ask me to find the maximum value. That was just me being extra and showing you eventually what we're going to be doing in the future. Sometimes in this course, sometimes in the next course, definitely in the future if you're headed towards calculus. All right, next slide. So this is going to be us using the graphing calculator on Desmos to solve each one of these. Okay, so now you can use a graphing calculator itself, and I can show you how to do that if that's what you want to do. But let me pause and get Desmos pulled up again. So we're going to start with, let's kind of zoom in here, and y equals negative 3x plus 20 is going to be one of my equations, and the other equation is y equals 5. Now the cool thing, so I put one equation on one side and the other equation on the other side. Okay, you can see I did that twice, and you can see one is a horizontal line and one is not a horizontal line. But we can find out that the intersection point between them is at 5, 5. So the x value is the solution to the equation. X equals 5. Now, that was pretty doggone simple to use Desmos to do that. Okay, so let's do a couple more of these things. Slide on over here, and we'll change this to, let's see here. If you type ABS, or y equals ABS parenthesis x minus 4, that stands for absolute value on Desmos. And then on the other one, y equals 1/2 x plus 1. Very straightforward. We can see that the absolute value function got shifted 4 to the right. We can see that the graph had a vertical shrink of 1/2, and it also got moved up 1 unit. But where do they cross? They cross at 2 spots. X equals 2 and x equals 10. Right? You can see that right there. The x value here is 2 and the x value here is 10. So the graph is showing me two solutions to the picture. It is sometimes useful. Now, when we get to solving these types of things in the next sections, you are going to have to show a lot more work. Would it be a smart idea to check it on a graph? Yes, it would be a smart idea. But the pictures, and maybe we should, for justification in this particular case, just, draw a quick sketch. We've got this shape coming through here like this. I didn't do a very good job on the slopes there, but I'm just doing a quick sketch. And you got this thing coming through like this. And so you can see here at 2 and here at 6, or no, 10. 10. 2 and 10. Okay. Okay. Make sure as we're going along doing this that you're practicing so that you can do it. It's one thing for me to be able to type on here y equals negative x squared. And to get the square, if you're wondering, I use the caret, which is above the 6. So shift 6. Then I get my 2 for squared. Then I have to use the right arrow to jump back down. Plus 3. Okay, so that gives me the parabola that opens upside down, right? It's got that reflection across the x-axis and the up 3. And of course, the other one is y equals 8. And, whoa, wait a second, they don't cross. What does that mean, folks? I hope you understand that that means no solution. Because the graphs do not cross at all. Okay, that's an important point that you need to understand. It is possible that you can have situations where there's no answer at all, right? So it's never going to happen. No solution at all. Well, what about inequalities? Like in example 2. So we want to know y equals x squared minus 4. We know that's a parabola. We know it's been shifted down 4 units because that's on the outside, and outside matches our common sense. And then y equals 0 is the other side. Now, that's also known as the x-axis. All right, so in this particular case, we are looking for, give me intervals where the parabola, in this case, that would be the left side, is above, not equal to. That's important. Above, not equal to 0. Okay, that's what's going on here. That's what they're asking me for. So, what are those intervals? Let's see if I can just arrow down. We want this section of the graph right here, and we also want this section of the graph. So, what is this section of the graph? We know that negative infinity is way over here. We know that positive infinity is way over here. And we know that that's negative 2 and that's positive 2. So, the answer to my question, parenthesis, negative infinity, I'm just going to use INF for infinity because yes, I can draw the infinity symbol. But since I'm typing, it would just be a lot easier if I don't. Now, I cannot use a bracket on negative 2. And so that goes back to this part right here, not equal to. You see how it doesn't have an equal to sign right there? It doesn't have greater than or equal to. If you would change this question, maybe I'll show you that here in a second. Union, parenthesis, 2, comma, infinity. Okay, so what happens What happens if this question changes? What happens if it's x squared minus 4 is greater than or equal to 0? How would that change my answer? Well, because now I could include 0, this is how it would change it. Negative infinity to negative 2. Oops, not parenthesis. Bracket, union, bracket 2 comma infinity. That would be the difference between these two questions. All right. So the question they asked me here and the second question I asked below that would have a modified answer just by changing those parentheses to brackets, because now 0 isn't a possible solution, so you must include where it equals 0 as well. Okay, let's slide over to the next one. X squared plus 5x. So this one's got that bracket in it, so, or that 0, so we're definitely probably going to be, seeing that bracket show up. In fact, I know we will, unless there's no solution, which we'll have to find out if there's no solution. Okay, so we got our two equations. The left side is this one, the right side is this one. Double check to make sure I didn't screw anything up. We got negative 5 and negative 1. So since we want greater than or equal to 0, we'll come back over here and we want parenthesis, negative infinity, comma, negative 5, bracket, union, bracket, negative 1, comma, infinity. Drink that down a little bit so it's not so ridiculous. But that's negative infinity all the way to negative 5. That's above the x-axis, right? I know they're asking me for above because they want to know when the parabola is bigger than the line, y equals 0. And then, of course, also happens over here from negative 1 to the right to positive infinity. Okay? Picture shows me everything I need. And let's slide this doggone thing over and do the next one. Okay, so y equals, get rid of this, x plus 3, and then y is equal to 7 minus 3x. So they want to know when the, I guess, for me, I know it's a different shade of green, when the green line is bigger, and I don't really, than the purple line. You can see the color choices that Desmos chose. Green line is bigger than the purple line. Now, I'm hoping that you see that that's over here on the right side of the graph, when the green line is bigger than the purple line. So this intersection point is kind of important to me, because starting right here at an x value of 1 and going to the right. Now, does it say equal to or not equal to? It is definitely not equal to. Okay, so let me not equal to. All right, so keep that in mind. So that means we're going to be using parentheses, right? Oops. Not equal to means we're only going to be using parentheses, not brackets. Okay? All right. Hopefully that makes some sense from what we just talked about a little bit ago. And then we can come down here and so it starts at 1 according to the picture and it goes to the right. The green one is higher than the purple one. So that would be parenthesis 1 comma infinity. Parenthesis 1 comma infinity. That's the only section of the graph. That's it. Nothing else. All right. Let's pause and go to the next slide. Zoom in so we have a better picture. A motorcycle is 40 miles ahead of a car. Motorcycle travels at an average rate of 40 miles per hour. The car travels at a rate of 60 miles per hour. When will the car be ahead of the motorcycle? Okay, so, let's see. Here's the starting point for the car. It's going to travel along at 60 miles per hour. Okay, let's let X represent the amount of time. Okay, but the motorcycle was over here 40 miles ahead, and it's traveling 40 miles an hour, so that's 40x. So we're really going to have two equations. So we're going to have y equals 40 plus 4x, or 40x, and then the other one is just y equals 60x, right? Because it started at 0. So if we jump back over here and do what we have been doing, you've got the motorcycle, 40 plus 40x, and then we have the 60x. Whoa, that's a weird looking graph. Let's see if we can figure out what this is going to look like. Let's see if I can stretch this. Notice that I'm stretching out the x-axis, but I think I need to stretch out the y-axis a little bit, or shrink the y-axis. So remember how to do that with your fingers. You have put 2 fingers on an axis, and then you can stretch or shrink just that one axis, and then we can easily find the intersection point. So it looks like after 2 hours, it'll be 120 miles. Now, remember, what was the question? When will the car be ahead? So my answer to this question is going to be after 2 hours, comma, the car will be ahead of the motorcycle. Now, notice I said after. I didn't say at 2 hours, because at 2 hours would be equal. They said, when will the car be ahead? So I have to go after to really be correct. All right, let's look at the next situation. Okay, so in this question, it says solve the equation using a table. I'm going to tell you right now, graphs are tables. Graphs are just visual representations of tables. So I feel like we're wasting a little bit of time. Oops, y equals. If we don't just use the same strategy we had before, right? Minus 4x plus 1. And then y equals x minus 2. Whoa, that does not look good. Let's go back to the original, negative 10 to 10. Oh, nice. So we can see an intersection point right there, and we can see another one right up there. So this is not an inequality. This is an equation, so we want the exact values. So our estimations are going to be, x equals, why isn't it typing? I thought I said x equals, we've got one answer at 0.69722, and x equals, you know what, we can just put a comma and then do another one. We don't need to say x equals again, because hopefully you already know 30278. We can see the two x values where the parabola and the line come together. Now, that's going to be an algebra part that we do later on this semester, is finding that algebraically, not just by graphing it. I hope that you can see that technology and graphing does speed up some really key components in life. So when you're doing things in a job, sometimes you're going to find relationships between things, and graphing technology is a very useful tool to helping you. Sometimes when you do these kind of things, this one's an unrealistic one, and then this, because sometimes you get a positive and a negative. We did not. We got 2 positives here. But sometimes you get a positive and a negative. and you have to throw away the negative because it doesn't make sense for the situation. Like if you're launching objects and, because a negative time would be before the object got launched, which doesn't make any sense. This situation obviously is not the same as that, but just as an example. All right, we'll go to the next slide. All right, so let's get back into our graphing. Y equals negative x squared plus 8x minus 13. And the other one, y equals absolute value x minus 4. Okay? Use decimals to approximate the solution to the equation. All right? Well, you know what? I'm going to change the question just for fun, because obviously the answer to the equal to here, I'll write this out. If we just do the equal to part, then obviously my answers are going to be x equals 2.69722 and 5.30278. All right. But let's just say, for fun, let's suppose I change this to greater than. Just greater than. So that means we want the parabola to be above. So let's go back and look at the picture here. We're talking about the parabola to be above. Now, isn't that just this section right here in the middle? That's the only part of the graph where the parabola is above the absolute value function. So if we're dealing with the greater than situation, then my answer would be an interval. And in this case, it would be from 2.697. Oops, can't type. I can speak it, but I can't type it. 9722. And yes, folks, I'm being a little dramatic by carrying that out with, 17 decimal places. We could have just done like 2 and that would have been fine. Something like this. And what if I changed it to greater than or equal to? How would that change my answer? Bracket 2.6. I'm just going to go to the second decimal place and be done with it since it's so long and drawn out. And the second decimal place on the next one just rounds to 5.3. And so in this case, how would it change my answer? It would just add the endpoints because it would be 0 it would be equal at that spot. So we would have it equal here and equal here. So you would have to include the brackets on the ends. So that's the difference. Okay, that's enough for that lesson. I believe we're done.